Right, so this is where we stopped. We were dealing with a 3 by 3 determinant. That means there are 3 rows and 3 columns. Okay, so what did we learn so far? We found the minor of a 3 by 3 determinant and the cofactor of a 3 by 3 determinant. Now, the question is to evaluate this whole thing. Right, so I gave you 6 here. I said evaluate the determinant, expand along row 1, and then column 1, row 2, column 2, row 3, column 3. There are 6 different ways to work this out. Let's start with the first way. So 2.1 is expanding along row 1. Right, so if you are expanding along row 1, then these are the numbers that you see in row 1. So what do we have to do here? We have to work out the cofactor of 2 multiplied by 2. The cofactor of minus 1 multiplied by minus 1. The cofactor of 3 and then multiplied by 3. Simple, it just takes a bit long to do, but nothing difficult. All you're doing is multiplying, that's all. Right, so let me just write this down properly. So this is going to be 2 times the cofactor of that 2. The next number there is minus 1 times the cofactor of minus 1. And the last number there is a positive 3 times the cofactor of 3. Right, so now the cofactor of 2, so this is going to be 2 times, so the cofactor of 2, so this is basically which row and which column. Check the row, check the column, which one is it?
Row 1.
Right, so you look at the row and the column. This is row 1, column 1. If you want to label it, you can. So this is row 1, row 2, row 3, that will be C1, C2, C3. That's column 1, column 2, and column 3. So if you look at this position here, it's row 1, column 1, so that's 2 times C1, 1. The next number is minus 1 times the cofactor of minus 1 is row 1, column 2, so that's C1, 2. The last one here is plus 3 times the cofactor of 3, which is row 1, column 3. Simple. Okay, so that's row 1, column 3. Now the actual working out. So this is going to be 2 times. Now C11, we know the formula for cofactor is Cij is equal to minus 1 to the power I plus j times Mij. Okay, so I'm going to do it in one step now. So I'm going to go minus 1 in brackets to the power I plus j. So that's 1 plus 1, which is 2 times Mij, that means M11. So what does M11 mean? It means block row 1, block column 1. Okay, so you block row 1, block column 1, so we are left with 1, minus 4, minus 3, and 5. So that is 1, minus 4, minus 3, and 5. Okay, the next one there is minus 1 times, so that's minus 1 times C12. So that's a 1 and a 2 now. So that's going to become minus 1 to the power I plus j. So if it's 1, 2, 1 plus 2 will give me 3 times, now block row 1, there's a jump. So you're blocking the row 1 out and column 2 out. So that's minus 2, 4, minus 3, and 5. So that will be minus 2, 4, minus 3, 5. Then our last one there is plus 3 times the cofactor of that 3. So that's C13. So that's going to be minus 1 to the power 1 plus 3, which is 4. And then you block row 1. So we block row 1 out and column 3. So we are left with minus 2, 4, 1, minus 4. So that's going to be minus 2, 4, 1, minus 4. Now, in the test or the exam, this is where you get the marks for this step. You don't get any marks for writing down the first two lines. This is for your understanding now. When you're practicing, you remember that it's 2 times the cofactor of 2 and all that there. Okay, again, this is where the marks are. Right, for this step here and then the final. So now, let's evaluate this. We need to make sure we don't make any silly mistakes here. So we got minus 1 squared. This is how you work it out. To work this out first, minus 1 squared is 1 times 2 will be 2. And then we got 1 times 5 minus 1. Sorry, 1 times 5 minus 4 times minus 3. Close your bracket. And then we have minus 1 to the power 3 is minus 1. And the minus 1 times minus 1 will give me plus 1. Now we evaluate this. That's going to be minus 2 times 5 minus 4 times minus 3. Here, minus 1 to the power 4 is positive 1. So positive 1 times 3 is positive 3. Work this one out. That is minus 2 times minus 4 minus 4 times 1. Now, you can go straight from here to your final answer, from this step to your final answer. And the main thing is you have this here to show that you're applying cofactor expansion, and then it's up to you after that. So that will be 2. So what do we have here? We got 5 minus 12 there. So this is minus 10, and this will be plus 12. This is plus 3. This is going to be positive 8 minus 4. Again, all unnecessary for you in the exam. You've got your calculator, you do it one time. Let's just check. So that's 2, 5 minus 12 is minus 7. So that's plus 1. 12 minus 10 is 2. 8 minus 4 is 4. So 2 times 7 is minus 14. 2 times minus 7 minus 14 plus 2 plus 12. So minus 14 plus 12 is minus 2 plus 2 gives me 0. Is that right? Double check in case I made a mistake, yeah? Do we get a 0? No. Yes? No? Let's double check. Okay, let's check the next one. The next one is column 1. First step, you'll all got the same thing. Okay. Now let's check column 1. Remember, we must get the same answer no matter which technique we use here. So expanding along column 1. Now let's do column 1. So in column 1, what do we have here? So in column 1, we have the numbers 2, minus 2, and 4. So we're going to go 2 times the cofactor of 2, minus 2 times the cofactor of minus 2, and 4 times the cofactor of 4. Okay, so I'm going to go 2 times the cofactor of 2, which is C11, then minus 2 times the cofactor of minus 2, which is row 2, column 1, and then the last one there is positive 4 times the cofactor of that 4, which is row 3, column 1. You clear with that? Now, I got 2 times minus 1 to the power 2, block row 1, block column 1, so that's 1 minus 4 minus 3 and 5. So that's 1 minus 4 minus 3 and 5. Then we have minus 2 times the cofactor of minus 2, which is minus 1. 2 plus 1 is 3. Block row 2. Block column 1, so that's row 2. Column 1, so that's minus 1, minus 4, 3 and 5. So that will be minus 1, minus 4, 3 and 5. And then we have a positive 4 times the cofactor here, which is minus 1. 3 plus 1 is 4. So block row 3, block column 1. So that's row 3, column 1. So that's going to be minus 1, 1, 3 and minus 3. Okay. Minus 1, 1, 3 and minus 3. Let's check now. Minus 1 squared is 1 times 2, which is 2. And then we got 1 times 5 minus 4 times minus 3. Minus 1 to the power 3 is minus 1 times minus 2 is a positive 2. Minus 1 times 5 minus 4 times 3. Minus 1 to the power 4 is 1 times 4, which is 4. So we got minus 1 times minus 3 minus 1 times 3. Let's double check all this here now. So we get 5, and this is negative, so that's 5 minus 12, which is minus 7. Okay. Then we got a plus 2 here. This is a minus 5 minus 12, which is minus 17. And what do we have here? That's going to be a 3 and a minus 3. Correct. Which is a 0. That's plus 4. That's going to be 3 and minus 3, which is 0. So we're getting minus 14, and then this is minus 34. So that's minus 48. Correct? Double check.
I think so, you made a mistake.
Where am I?
Minus 36.
By the 4, so it's 4, it's negative 4 times 3. The second one, the second cofactor.
Yeah.
No, the 4, yeah, that 4.
Oh, okay, sorry. That's a negative 4 there, yes. So that's minus 4 times 3, so that's going to be a 5, and this is a plus 12, which is 7, correct? So that's going to be, let me just work this out, minus 1 times 5 is minus 5, negative times negative is a positive, 4 times 3 is 12, so that's 12 minus 5, which is equal to 7. Correct now?
Yes.
Alright, so yeah, there's a mistake here. So 2 times minus 7 is minus 14, 2 times 7 is plus 14, and then 0 times anything is 0. So minus 14 plus 14 gives us 0. Alright, so yeah, that's why you can be careful with the negatives there. You can see that, the signs and everything. So you can see we get the same answer for expanding along row 1, expanding along column 1. Let's do row 2 while we are at it. Now you all did not get 0 for this one. You got 0. Okay. So there's no need for me to go and do row 2, column 2. We are expecting the same final answer. Okay. Alright, so now we need to deal with the 3 by 3 determinant solving for x, y, and z. Alright, I'm just going to start you off with this one here and give you a few minutes. So here we're solving for the unknown variables. According to this exercise, solve for x, y, and z. We are just going to work out y only for this one, and we'll take a different example after this. Right, but in the exam you will only be asked to work out for either x only, y only, or z only. Now, Here you're given a specific instruction, expand along row 3. That means you need to use the method of cofactor expansion, just like what I was doing a few minutes ago. You're not allowed to use the other method, which I'm still going to show you, where you copy down column 1, 2, 3 and column 1, 2. Right, so if you are working out y, then it's going to be dy over d. So what do? Just like how we were working out the 2 by 2. Two equations with two unknowns. Let's write down our d first. So d is called the determinant of the coefficients of x, y, and z. So make sure that all your equations are in order. Clearly they are in order. You've got all the unknowns on the left, constant on the right. So coefficients of x, we got 1, 1, minus 1, 1, 1, minus 1. Coefficients of y, 1, minus 1, and 1. So that's 1, minus 1, and 1. Coefficients of z, 1, minus 1, minus 1. So that's 1, minus 1, minus 1. So here we evaluate this. There's 6 different ways to do it. You can't do any way you feel like. You expand along row 3. The other examples, we expanded along row 1, column 1. So you're going to work it out here. Then what about dy? Then for dy, what do? We will replace the coefficients of y from here. Replace the coefficients of y with the constants. C1 or D1, D2, D3. So what am I doing? Replacing the y column with 0, 3, and minus 4. The x column and the z column will not change. What is the x column? It is 1, 1, minus 1. 1, minus 1, minus 1. And now, work it out. Only by expanding along row 3. No other way you're allowed to do it. In the exam, if you're given no instruction, then it's up to you what method you want to use. But here, it's clear. So, I'm going to give you just 2 minutes there. You should be getting fast at it. So, let's work out dy and d. Okay, so now, the question states, expand along row 3. So, here's row 1, row 2, row 3. So, here's my row 3. Right, so now, we're going to go minus 1 times the cofactor of minus 1, which is minus 1 to the power, which row and which column is this? Row 3, column 1, so that will be A4. Right. Then, we block the row and we block the column in which minus 1 lies. So that's block the row, block the column, so that's 1, minus 1, 1, minus 1. So that's 1, minus 1, 1, minus 1. What's the next number then? The next number is a positive 1, so it's plus 1 times the cofactor of that 1. To find the cofactor, you go minus 1 to the power row plus column. Which row is this? Row 3. Which column? Column 2. So 3 plus 2 will give me 5. Times, now block the row, block the column. So we are left with 1, 1, 1, minus 1. So that's 1, 1, 1, minus 1. What's the last number there? Minus 1. So that's going to be minus 1 times the cofactor of that minus 1. So cofactor is minus 1 to the power row plus column. Row 3, column 3, 3 plus 3 will give me 6. Now block the row, block the column. So that's 1, 1, 1, minus 1. Okay, just make sure you double check this step over here. One mistake and then everything goes wrong. Alright, so now I'm going to go minus 1 to the power 4 is a positive 1. Positive 1 times negative 1 is negative 1. Okay, this one I'm going to work out. This is going to be minus 1, minus, minus, minus 1 plus 1 there, which will give me 0. Okay, here minus 1 to the power 5 is minus 1 times 1 is minus 1. Here we're going to go minus 1 again, which is minus 2. Minus 1 to the power 6 is a positive 1 times negative 1 is negative 1. Then here we're going minus 1 down, minus 1, which is minus 2. So now 0 times anything there, 0, negative times negative, positive 2, negative times negative, positive 2. So we get 4, you are correct, so we get 4 for D. Okay, so that means for dy we should get minus 8, because minus 8 divided by 4 is going to give me the minus 2 that we just checked using the calculator. Alright, so that was my D. Let's work out dy now. So same thing now, you can see that for all the examples. You're going to go minus 1 times the cofactor of minus 1. Minus 4 times the cofactor of minus 4. And then minus 1 times the cofactor of minus 1 there again. So I'm going to go minus 1 times the cofactor of minus 1, which is minus 1. Row 3, column 1. So that's going to be the power 4. Times, block the row, block the column, 0, 3, 1, minus 1. So we go to 0, 3, 1, minus 1. What's the next number here? Negative 4. So we're going minus 4 times the cofactor of this minus 4. So that's minus 1 to the power row plus column. Row 3, column 2, 3 plus 2 is 5. So now block the row, block the column. So we are left with 1, 1, 1, minus 1. So that's 1, 1, 1, minus 1. What's the last number here? Minus 1. So that's going to be minus 1 times the cofactor of minus 1, which is minus 1 to the power row plus column. Row 3, column 3, 3 plus 3, 6, block the row. Block the row, block the column, 1, 1, 0, 3. So that's 1, 1, 0, 3. Okay, just you need to be careful with this, yeah? So now, minus 1 to the power 4, positive 1. Positive 1 times negative 1 is negative 1. Evaluate 0 times minus 1, 0. Minus 3 times 1 is minus 3. Minus 1 to the power 5 is a negative 1. Times negative 4 is a positive 4. Here we're getting minus 7, minus 1, which is minus 8. Minus 1 to the power 6. Positive 1 times negative 1 is negative 1. Here we're going 3 minus 0, which is just 3. So now a negative times a negative is a positive. 4 times minus 8 is minus 32. Minus 1 times 3 is minus 3. Where did we go wrong?
It's not a 8 here, so it's a negative 2. So.
Sorry. Why did I write down? So that's an, yeah, sorry. 1 times minus 1 is minus 1. Minus 1 is minus 2, so that's a minus 8. So that's a minus 8. So 3 and minus 3. So that's minus 8. Now, y is equal to dy over d. So my dy is minus 8 and the d is 4, so we get minus 2. So it is not difficult, it's just that you need to practice so you don't make any mistakes when copying down signs. The main thing is in the beginning. we need to make sure these equations are in order. Okay, we're going to take another one now. Alright, so going back to this example, now let's say you're given the question in the exam. The question states use Cramer's rule, solve for y. They don't tell you which row or which column to use. Okay, so most of the time, the exam memo, the memo that comes about, they use row 1. You know, by default, it's always use row 1. Or there is another technique which you can use. It will only apply to a 3 by 3 determinant. Like if you go higher up to 4 by 4 and all, then it won't work. This method that I'm going to show you now. Okay, so this is it. You can work out D by simply writing down column 1, column 2, column 3, and then you copy column 1 and column 2. What do I mean? You copy it down with 1 minus 1, 1 and minus 1, so there's a 1, 1, minus 1. Then the next one is 1 minus 1 and 1, 1 minus 1 and 1. Okay. Now what do you do now? Just like how we did the 2 by 2 determinant, we are going to multiply in a diagonal. So you start from the first number and you're going to multiply going down. So you're going there diagonally. You're not going up or down, so you're going to go like this here. You're going to multiply these numbers here. So this is equal to, I'm going 1 times minus 1 times minus 1. Can you see that? Then I'm going to go with the next number. I'm going to multiply diagonally going down now. So I'm going to go like that. So this is going to be plus. I always put a plus sign. And then I'm going to go 1 times minus 1 times minus 1. Going down. This is not using cofactor expansion. Okay. But you can still use it if they don't give you any instruction. This is the easiest thing to do. You can see that. What's the last number that you have there? You got 1, you got 1, you got 1. Here's another one there. So you're going there, and then you put a plus and multiply. That's going to be 1 times 1 times 1. Now, those are the numbers when you multiply going down. Now, we also have numbers going up. Remember when we multiply, you multiply going down, then you put a minus sign, and then you multiply going up now. So we're going to do the same thing, the diagonal. So we start at the bottom, first number, and then you're going up there. So that's a diagonal 1 there. So that's your 1. But this time, you must put a minus sign. So it's a minus, and then we're going minus 1 times minus 1 times 1. What's the next one? You go up there, so you're going there. So there's another one. So that's, you put a minus again and multiply. What numbers do we have now? 1, minus 1, and 1. So that's going to be 1, minus 1, and 1. And finally, the last number here. You're going to go up there and down there. So that's going to be minus 1, 1, and 1. So let's put a minus sign. Always a minus first, and then minus 1, 1, and 1. And that's in one step. Okay. So let's work this out. So negative times negative, that's a 1. This is going to be plus 1 here. This is going to be plus 1 again. This one will be minus 1. This will be a plus 1. This will be plus 1. Let's see what happens here now. So we get 1, 2, 3, 4, 5. Minus 1 is 4. We had 4, correct? So this is copying down column 1 and column 2. Okay, so this is an alternate method. If you don't see any instruction here, it just says solve for y. You can use, basically you can use cofactor expansion, any row, any column, or this will be a much easier way to do it. Okay. But if you see the word expand along column 1 or row 1, then you cannot use this technique here. You will get 0 for the step. Okay, you get only 1 mark for the final answer. So here you can do it again. You can work out dy. What you're going to do is column 1, column 2, column 3, column 1, column 2. Draw your diagonals going down, going up, and it's sorted. And you can check in the textbook too. Simple. Let's deal with one more then. This time we're sticking with cofactor expansion. Alright, let's start working this one out. So we have three equations with three unknowns. The question here is solve for I3 only. So step number one is to rewrite all your equations in order. So let's take equation number one. We got 4I1. Now we got plus 6I2. But notice we are working on I3, but there is no I3. So you will write it as 0 multiplied by I3 is equal to 9. Because 0 times anything is 0. So that is your equation 1. Equation 2, that will be 4I1. Notice there is no I2. So that will be plus 0 times I2. And then we got plus 10. I3 is equal to 9 again. Then equation 3 we got I1. And then it's up to you whether you want to take it to the right or to the left. I'm just going to take everything to the left, so it's minus I2 minus I3 is equal to 0. Right, so now we have all those equations in order. So we're working out I3, so we know the formula for I3. So I3 is going to equal to, we need to find di3 over d. So let's find d first, the determinant of the coefficients of I1, I2, I3. So the coefficients of I1, I2 and I3 are, so we got 4, so there's a chair, 4, 4 and 1, then we got a 6, 0 and minus 1. And the last column there is 0, 10, minus 1. So that will be 0, 10, minus 1. So here I'm giving you a specific instruction. So you cannot apply the other technique that we just used now. We're going to expand along column 3. So all the numbers in column 3. You notice now, whenever there's a 0, it's easy to work out because you're only working out these two, because the first one is 0 times anything will be 0. But let's just write it down. So we are expanding along column 3, so it's going to be 0 times, that's going to be C13 plus 10 times, that's going to be C23, and the last one is minus 1 times C33. Right, so that's row 1, column 3, row 2, column 3, row 3, column 3. Then the columns must always be 3 because we are only using column 3, no other column. So now we know here 0 times anything is 0. There's no point in writing down anything because 0 times anything is 0. Here, so that's going to be 10 times, that's going to be minus 1, 2 plus 3 is 5, block row 2, block column 3, so that's there, 4, 1, 6, minus 1, so that's 4, 1, 6, minus 1. Right, then we got a negative 1 times minus 1, 3 plus 3 is 6, block row 3, block column 3, so we got a 4, 4, 6, 0. So that's going to be 4, 4, 6, 0. You got that? Alright, so now let's work this out. Minus 1 to the power 5 is minus 1 times 10 is minus 10. So here we got minus 4, minus 6, which is also minus 10. Correct? Minus 1 to the power 6 is a positive 1 times negative 1 is negative 1. 4 times 0 is 0. Minus 4 times 6 is minus 24. So negative times negative is a positive 100, negative times negative positive 24, so that's 124. I've got 124. So that is D. Now, let's work out DI3. So for DI3, we replace the I3 column. In other words, the coefficient of all the I3s here, which are, there's a check. Replace these ones with your constants, 9, 9, and 0. So that's going to be 9, 9, 0. I1 and I2 column will remain the same, which is 4, 4, 1, 6, 0, minus 1. And we're still evaluating along column 3. So that was the instruction there. Evaluate, expand along column 3. So this is going to be 9 times C13 plus 9 times C23 plus 0 times C33. Row 1, column 3, row 2, column 3, row 3, column 3. So this is going to be 9 times minus 1, 1 plus 3 is 4. Block row 1, block column 3, so we are left with 4, 1, 0, minus 1. Next one is plus 9 times minus 1, 2 plus 3 is 5. So now we got block row 2, block column 3, so we are left with 4, 1, 6, minus 1. And the last one here, we're lucky when we have a 0 because 0 times anything will be 0. Yeah, the last one. So let's work out this here. Minus 1 to the power 4 is a positive 1 times 9 is 9. Here we're getting 4 times minus 1, which is minus 4. The other one is a 0 there, so you don't have to worry about that. Minus 1 to the power 5 is minus 1. Minus 1 times 9 is minus 9. And then we got minus 4, minus 6, which is minus 10. So we get 9 times minus 4, which is minus 36. That times that will be a positive 90. So we get a 54 here for DI3. Is that correct? 54 for DI3. So therefore, I3 is equal to DI3, which is 54 divided by 124. Can be simplified further. That's a simplified answer here. (27 over what? 68?
62.
62, sorry. 27 over 62. You can check on your calculator. It should give you the correct answer. Now, for an example where we have, some of you all were asking me what happens when you have like, let's say, 1 over x plus 2 over y is equal to, let's say, 4, and maybe you have 3 over x plus, let me put a minus here, minus 4 over y is equal to minus 2. There's an example there in the exercise. I'm going back to the 2 by 2 now, the one that we were dealing with last week. So notice x and y are in the denominator. Can you see that? It's an unusual type of question. So what do we do with unusual stuff? We always use a substitution. Remember, we're using k substitution in N3. There's nothing stopping you from using a substitution here. So in a case like this, what would you do? You can let 1 over x, let's say, equal to, let's call it p, and 1 over y equal to q. So what will I do in a situation like this? So I can replace. So I got my 1 over x there. I can write 1 over x as p plus 2 over y. What will 2 over y be? Because 1 over y is q. So what will 2 over y be?
It's 2
So that's why you need to understand a simple fraction here. 2 over y is the same as 2 multiplied by 1 over y. Can you see that? So what is 1 over y? It's q. So therefore 2 over y will be 2q is equal to 4. Equation number 2, 3 over x. If 1 over x is p, I don't have to show you again, huh? What will 3 over x be? If 1 over x is p, 3 over x will be 3p. And then we got minus 4y, so that's minus 4q is equal to minus 2. Now let me have a calculator, let me do this fast. Right, so what I want to do now is, I'm going to work out my new equations in terms of p and q. So I'm going to go p is equal to dp over d, and then q is equal to dq over d. So I'm going to, let's see what's my p. So let me go for equation number 1. So we got 1, 2, 4, then we got 3, minus 4, minus 2. So I'm getting p, it's called x on the calculator, but it's actually p that you're working out according to what's on the board. So what did I work out now? I've got p is equal to 6 over 5. So let me just write that down. So I've got p is equal to 6 over 5 and q is equal to 7 over 5. But what was the original question? The original question was solve for x and y. Right, that was the original question. But we rearranged it to make it simpler and we solved for p and q. So I got my p is 6 over 5. So now, what do I know about p? I know that p is equal to 1 over x. Can you see that? So that means, in place of p, I must write down 1 over x is equal to 6 over 5. And then q is equal to 7 over 5. In other words, 1 over y is equal to 7 over 5. Now I have a simple equation. If I invert the left hand side or cross multiply, however you want to do it, x over 1 is equal to 5 over 6. If I swap numerator and denominator on the left, I must swap numerator and denominator on the right. Okay, or cross multiply and divide, however you're thinking. If 1 over y is equal to 7 over 5, so therefore y over 1 is equal to 5 over 7. And that's how you deal with any question where you have the variables in the denominator here. Can you see that? Use a substitution, work it out, and then it will work out fine. Right, so now we move on to, we're starting off with some complex numbers.